Welcome to Metals 101. Today's video is all about welding stainless steel, a process that's a bit more complicated than welding other metals. We're going to dive into the techniques, materials, and challenges involved. If you're ready to learn how to get strong, clean welds on stainless steel, let's get started. Welding stainless steel is unique because of the material's chemical composition. While stainless steel is an alloy of iron and carbon, it stands out for containing at least 10.5% chromium, which gives it corrosion resistance. But that same chromium makes stainless steel tricky to weld, as it reacts differently to heat compared to carbon steel. There are three types of stainless steel you'll most commonly encounter when welding: austenitic, martensitic, and ferritic. Each type has its own specific properties and challenges. For example, austenitic is the most commonly used stainless steel and is known for its versatility. Martensitic is harder and used in more demanding applications like hard facing, while ferritic stainless steel is more cost-effective and often found in consumer products. When it comes to welding stainless steel, one of the first things to understand is that it retains heat more than carbon steel. This means it can easily warp when exposed to the high temperatures of welding. Not only that, but it can crack as it cools down, so managing heat is a crucial part of the process. Even when you avoid these major issues, stainless steel is also more prone to showing scratches and blemishes after welding. Each type of stainless steel presents its own unique challenges during welding. Austenitic stainless steel can crack if exposed to excessive heat, or if a concave weld is made. Martensitic stainless steel can be brittle and requires preheating to prevent cracking. Ferritic stainless steel has a low interpass temperature, so if it's overheated during welding, it will lose strength. Each type of stainless steel needs careful attention to temperature and technique. A key to welding success is choosing the right filler material. The filler material needs to match the base material you are welding to ensure a strong bond. This will also maintain the corrosion resistance that makes stainless steel so valuable in various applications. There are several welding methods you can use, but when it comes to stainless steel, the three main processes are stick welding, MIG welding, and TIG welding. While you can use stick welding, it's not usually the best choice for stainless steel. MIG welding is preferred for thicker materials because it produces a strong, reliable weld. If you're working with thinner stainless steel or need more precise, cleaner welds, TIG welding is the way to go. For MIG welding, you'll need a machine equipped with a welding gun and welding wire that's suitable for stainless steel. It's a good idea to have extra gun tips on hand, as they will wear out over time. A liner can also help when you need to switch between different wire types quickly and efficiently. When selecting welding wire, the most common choice is 0.030 inches in diameter, but you might want to go thicker, up to 0.045 inches, if you're working with heavier material. Keeping an eye on the temperature during welding is critical, so use a temperature tracking device like an infrared thermometer to monitor the heat and avoid issues like warping. You'll also need to use the correct shielding gas. For stainless steel, a good mix is 7.5% argon, 90% helium, and 2.5% carbon dioxide. This combination helps protect the weld area from contamination without causing adverse effects on the stainless steel's properties. Before you begin welding, it's important to prepare your workspace properly. Use a metal brush to remove any dirt, dust, oil, or other contaminants from the stainless steel surface. This will ensure a clean weld. To prevent warping and cracking, try clamping a piece of brass or copper behind your weld seam. This absorbs some of the heat and helps keep the stainless steel cool during the process. A critical tip is to keep a separate set of tools for stainless steel. If your tools have touched carbon steel, they could transfer carbon residue onto the stainless, which can lead to rust down the line. This is an often overlooked but crucial step in achieving a long-lasting, corrosion-resistant weld. Now, let's talk techniques. For TIG welding, use a DCEN, direct current electrode negative setting, and set your current to 1 amp for every 1/1000th inch of material thickness. For MIG welding, use the push technique, which gives you better visibility of your work and minimizes beading. Only use the pull technique if you need deeper penetration for the weld. When holding your welding gun, keep it at a 90-degree angle and use a 15-degree travel angle for most welds. If you're welding T-joints or lap joints, increase that travel angle to around 45, 70 degrees for better penetration and strength. Even though welding stainless steel is more challenging than other materials, it can be done successfully with the right preparation, equipment, and technique. You can even weld stainless steel to mild steel with careful management of temperature and filler material. Thank you for watching. We hope this guide helps you master the process of welding stainless steel. Be sure to subscribe to Metals 101 for more tips, and feel free to leave any questions or comments below. See you next time.